Good afternoon. I'd like to start our class today. Okay, once again, here is the table of contents of our lecture note. In the first week, we briefly introduced the hydrogen gas, global trend, and policies. And chapter 2, which we covered last week, hydrogen productions. In fact, chapter 2 and chapter 3, we discuss about the hydrogen productions and conventional versus emerging method. We review all the hydrogen production with the color, different colors, gray, blue, and green. And also we reviewed yellow, white, and pink hydrogen. And it is important to understand energy input and efficiency and scalability challenges. Now, today, we like to more focusing on green hydrogen. Green hydrogen is the most typical way of hydrogen production method. So, chapter 3. Again, chapter 2 is the hydrogen review of hydrogen production with the different colors. There are some here, chapter 3, green hydrogen. That's the one we like to cover today. So chapter 3 starts with the green hydrogen and advanced production technique. Other advanced production technique were reviewed last week. So again, we like to focus on the green hydrogen. Okay, focusing on green hydrogen, this chapter details electrolysis. Okay, electrolysis using renewable energy. The two typical method is alkaline and PEM method. We like to study about the alkaline and PEM method alongside advanced variant, yellow. Yellow hydrogen means that the solar directly produce hydrogen, and white, well, geologically the hydrogen can be stored in the underground. This is the one of the amazing way of production of hydrogen, most ideal, but it is still on the way. And nuclear driven production. So anyhow, the green hydrogen is the $3 to $6. There are several methods, as we know, production of hydrogen by color. But the most important point is the price, how much it will cost to produce hydrogen gas. So green hydrogen will cost hope to cost $3 to $6 per kilo. Well, this cost would depends on the material we use and the efficiency of this method. And leverage solar and wind. These are two most typical renewable energy for zero emission. Again, the green hydrogen is the very clean, no CO2 emissions. And so a lot of technology have been developed for these green hydrogen productions. And there are some more values which would be nice to understand. With 1 megawatt electrolyzer productions, 20 to 25 kilo daily. So electrolyzer can have a capacity, usually the power, 1 megawatt electrolyzer. It's good to understand the capacity. Electrolyzer produce 20 to 24 kilo. Well, to better understand the hydrogen mass, would be nice to understand in a way that we need about the 6 kilo to fully for full tank in a Nexo. So this amount is what about the 4 vehicles. I would say the 4 Nexo can be fully charged daily with a 1 megawatt electrolyzer. Again, in other words, 1 megawatt electrolyzer can produce this much 20 to 20 kilo of daily hydrogen. And yellow, and the okay, so a green hydrogen via electrolysis. So green hydrogen, there are some descriptions, alkaline, 2 methods, alkaline and PEM. That's the one we like to focusing on. Again, we can go through all the figures for us to better understand characteristics of this electrolysis green hydrogen. We have some okay. This is the explanations of difference between the PM. The PM method can be used to generate hydrogen, electrolysis, and also the reverse procedure will be a fuel cell, PM. But before this, I like to, just 1 second. Okay, the alkaline electrolysis and PEM electrolysis. Uh, these are two most typical methods of electrolysis for the green hydrogens. And all we need is the water, H2O, as you can see here, H2O, H2O, and then power. Power is represented by the cathode and anode. Uh, and of course, we need a current here and here. So if we, okay, PM electrolysis, the temperature is the 22, 100 Celsius,
그치? 아, 뭐 먹을까?
little higher, higher temperature.
그래, 그래.
Okay. So PM operate the temperature ranging from room to 100 Celsius. And again, the water comes in to anode side, plus anode side. And then here, briefly speaking, the protons, H plus, will transmit through a membrane. This membrane is called proton, proton H plus, proton exchange membrane. And this proton transmit through this membrane, and then H2, H plus, together with this electron from a cathode, produce H2. Here is the formula. Uh, Proton plus the react with the electron, giving us the hydrogen gas. That's the how we got a H2 hydrogen, and then anode side, this water again is separate into protons, and then we got oxygen here, and plus electrode. So the altogether, we can say H2O, water, is split into hydrogen plus oxygens. Whereas the alkaline electrolysis, again, all you need is water, H2O, and then power. The operating temperature is a little bit lower than PEM. And the water, this water plus the electron in cathode side, there we generate H2O by splitting OH minus. OH minus is a go into anode side, and then it will be a O2. That is the what's going on is anode side. So again, the basically total reaction will be the same as the PEM, but the major difference is that which ion is a travel. I mean, here is a OH minus travel, here is a travel, proton travel, and then the hydrogen generate in cathode side, H2 here and H2 here. So Actually, the alkaline is the more conventional method, operate a little lower temperature, and the efficiency is a little bit lower than PM. PM is the high efficiency wise is higher than alkaline, but the initial investment for the alkaline this method is the cheaper than PM. So PM method, we need a little more expensive initial investment. Okay, well, same explanations, but I like to more focus on the PEM, proton exchange membrane. Again, as a H2O goes into a anode side, H2O comes here, and then this electron, and importantly, the proton is separated. There will be oxygen here, O2. So basically, proton, oxygen, and electrode separated. This H plus is traveled through the proton membrane, and the cathode side, this meet with the electron. So basically, the proton react with the electron, giving us the hydrogen gas. So the output from this cathode will be the hydrogen gas. Now, here the most important point is that we need a catalysis. Here is the okay, I have another pictures. Okay. Here is the cathode electrocyte and the anode electrode and anode cathode and anode electrode. You know, we need an electrode, and here is the very expensive material are needed. Platinum, PT, and the IRO2, like the so these are very expensive materials. So that's why the initial investment is much higher than alkaline method. Alkaline method is the less expensive as the initial investment. But again, the efficiency-wise, the PM, this is the works better than alkaline. So I would say this method is the more advanced method than alkaline. So a lot of research is being going on right now to develop this PM method. Same figures, but the okay, but this is the simple animations. Well, it's the same explanations, but with a little bit animations. H2O, water, goes into anode side, and then this split proton, and then there will be the oxygen comes out, and this proton travel through this proton membrane, exchanging membrane, go into here, and now here we need a electricity electron meet the proton, giving us the hydrogen. So the output hydrogen comes from the cathode side. Certainly, we need a lot of power and energy going on here. So the look here, electron travel for this traveling. We need a power. Uh, this power can be from a solar cell. Power can be from a wind turbine blade. So basically, or theoretically, all we need is the power from renewable energy, such as the renewable solar cell and then wind power, and also we need water. That's all we need. So once we have installations, the cost, it costs nothing. All is from water, cost is almost nothing, and then solar cell cost, the solar power is almost nothing. So this is the most ideal way of generation hydrogen PM method. Actually, there are good reference and in Wikipedia. I highly recommend you to review this Wikipedia explain the proton exchange membrane electrolysis PM. There are some the formula explanations and the history, advantages, and the science involved in these procedures, reaction. Again, the anode side and cathode side. This animation comes from here. So how much energy we need? So we have explanations. Well, hardware-wise, we as an engineer need to understand, or we hope to have a very small PM electrolyzer. So I like to copy this, save it here. There is some YouTube giving us the simple way of assembly of this PM, and then we can required parts. Again, this YouTube is giving us the practical way of assembling PM. So let's take a look at like the about the 5 minutes, and how can we make this simple PM hydrogen generator.
Aluminum alloy plate, insulated gasket, titanium alloy positive and negative electrode plate, titanium mesh, silicone gasket, microplate, important viewpoint, 117 here, gasket, nut, gas pipe connector, electron.
Oh, actually, these are
gasket, nut, gas.
These are all the materials we need to have to build this PM hydrogen generator. Well, aluminum alloy plate, insulated gasket, which is a kind of insulations, and titanium alloy, positive and negative electrode plate, uh, and titanium mesh, which works as an electrode again, the silicon gasket and microplate, and imported DuPont N117 PM. This is basically the PM. Again, the proton exchange membrane is the one of the most mature we need to have. We need in the PM method, and screw and gasket and nut and well, a gas pipe connector. This is all we need.
Gas pipe connector, select an aluminum alloy plate as the pressing board.
So simply, again, this video is giving us the real practical understanding of PM, and this we can certainly follow this procedure to make the very small scale, lab scale, the PM electrolyzer, which really works. This is the aluminum plate as a basis, and also work as a electrode.
With the prepared screws.
And reverse.
Install the insulated gasket. Pay attention to the position of water inlet and air outlet. Install titanium alloy positive and negative electrode plate. Install the sealant silicone gasket. Install titanium mesh. Titanium mesh shall be placed in the order of high, medium, small density. Place them neatly. Install the microplate. Align the titanium mesh when placing. Install DuPont N117 PM.
Okay, this is the PM. So through this PM, proton will travel.
The PM shall be installed carefully to avoid damage. Install the microplate. Install the studio sealant silicone gasket. Install titanium mesh. Titanium mesh shall be placed in the order of high, medium, small density. Align the microplate and place it. Install titanium alloy positive, negative electrode plate. Install the silicone gasket. Install the second titanium mesh. Titanium mesh shall be placed in the order of high, medium, small density. Install the microplate.
Actually, this is a multi-layered of this exchanger. The cathode and anode, and between them we have a PM, and then also starting with the anode and cathode and etc. So this can be multi-layered, as many as needed to produce a certain level of the hydrogen gas.
Find the titanium mesh when placed. Install DuPont N117. Install carefully to avoid damage. Install the microplate.
So this is the
Attention to the
same
position of water inlet to the pump.
repeat.
Install aluminum plate. Install gasket and tighten the screws based on the standard contractants and torsions. Install the air pipe connector and tighten. Water inlet, hydrogen outlet, and oxygen outlet shall be distinguished.
Well, just for the reminder, and the we have a inlet H2O, and there will be an outlet cathode side and the anode side. Okay, this is the connector on both sides. See, in the anode side, I mean there will be a water and then hydrogen in the oxygen, and the other side will is for the hydrogen.
Installation complete. Test after assembly.
Right.
Check whether there is resistance.
We have
whether there is short
this
circuit
side.
between electrode and pressing plate.
So we need to confirm that all are
Test is moving. Go on power on
insulated.
test. Connect to water pump.
So again, very simply, all we need is just the water inlet and then power. Then output will be the hydrogen gas and oxygens.
Connect the air pipe. Connect to output bus. Bus plug is connected to the transformer. The control transfer line connector is connected to the transformer. The signal line connector is connected to the transformer. The input bus plug is connected to the transformer. Connect the water level sensor line of the control transfer line to the tank. Connect the water pump line controlling the transfer line to the water pump. Unscrew the upper cover of water gas separator. Pour in purified water. Turn on the switch. During inspection, whether hydrogen and oxygen are normal. Check whether the voltage and current are normal. Check for water leakage. If there is no problem in the test, installation is completed.
Okay.
Can you guess what this is?
We just reviewed the PM method. We can see how easy we can build such a PM electrolyzer. Well, this one is another device for the fuel cell. Fuel cell is the reverse procedures. Is with the hydrogen gas input, now we can generate electric. And okay, since we are here, let's quickly review this one as well.
But this is called a fuel.
Actually, this device is on sale right now. We can buy them through AliExpress, and there are several sites where we can buy.
Fuel cell. It generates electricity from the fuel in the chemical reaction. To be more specific, it is hydrogen and oxygen. These different classes that we are now seeing potentially conduct into electrical energy. Like take water, for example. And by the way, this also do. So be careful with that. But anyway, I want to explain to you the entire process of getting energy from water. And like that, you should understand how the hydrogen car works, how the fuel cell will generate electrical energy. I promise you this will be a very interesting experiment. So let's get started. Okay, so for today's experiment, I'll use two devices. One is the fuel cell, and the other one is the electrolysis device. And don't worry, I'll go over each one in a moment. But you see, the hydrogen vehicle could be of two types, combustion or electric. But before explaining the differences, just a few words from our sponsor. Hey guys, this is the way sponsored this video, and let me just tell about their service. For example, look how often they're prototyping and you can get this for only $5. As I was telling you, hydrogen cars could work with a combustion engine or an electric motor. Hydrogen is quite explosive and energy dense. You could use it just as a gasoline motor and create controlled explosions, moving pistons and so on, just as a normal combustion motor, but adapted.
Okay, this introducing a very conventional method of using the internal engines. Now this internal engine, instead of a gasoline, we can supply hydrogen in. So in this case, of course, with this, we can use them as the mechanical power. In this case, without any fuel cell, which generate electricity, but in this case, we don't need a fuel cell. We just need a hydrogen in, and then we can, this engine can operate. This is the hydrogen internal combustion.
Adapted to hydrogen. But that is not very efficient. Actually, it's less efficient than a gasoline motor. But on the other side, instead of combustion, hydrogen, we can use it. That is more efficient than a combustion engine. This type of car is exactly as any electric car, such as the Tesla car. But instead of using batteries, we use electrical energy. Hydrogen in a high pressure tank. Energy also as waste water.
Imagine that we have a hydrogen gas in a tank. Again, we review that about the 2 kilogram of hydrogen in one tank. And with this hydrogen gas, to generate electricity, to operating this electric motor, what do we need? We need a fuel cell. So fuel cell thus generates the electricity with this H2 input, and then output will be another output will be just water, and then hydrogen, the oxygen. So as you can see, the fuel cell is the exactly reverse procedure of the electrolysis, such as a PEM method.
The energy is then passed to the motor. That's how it works. All right. How about the
Now here we like to understand fuel cell, which we will cover a few more chapter later, but this is just the with understanding right after PM. So it's good to see, good to review this PM fuel cell.
let's go step by step from everyday electronic and what is for only 7 days.
Okay, as you can see that we can easily buy the electrolysis, AliExpress, and a very cheap price.
Also AliExpress. Only each one plastic containers and metal pellets. And anyway, this device has 2 metal rods fully supplied. Put this together. And what is water right now? Water to split the atoms, fluid must pass from water from one electrode to the other one. So the touch is no more water. But the water is enough. And then we access sodium hydroxide to act as a good electrolyte. So we have a better flow of ions between the anode and the cathode. And you can get this for just $2 on Amazon. But make sure that you make it in contact with it. Otherwise, it may burn your skin. And before we make the experiment, let me show you how electrolysis works. We have a plastic container with 2 electrodes. We apply positive at this electrode and negative at this one. Then we add water. We also add some sodium hydroxide, so now the water is conductive enough, so the current flow is created into the electrodes. And when the current passes, the ions migrate to the electrode with the opposite charge.
Okay, this is the as we reviewed, there are 2 methods, PEM and alkaline method. So this is the other method, alkaline. So again, this is the electrolyzer. With the power in, we can generate hydrogen.
At the cathode, these sodium ions will be electron. Sodium ions will be the cathode, and hydroxide ions will go towards the anode. The water also needs a pump. Here we use the pump for H2. The other side of the hydroxide ions produce electrons that oxidize to form oxygen gas, and also water. Overall, the electrolysis of sodium hydroxide water produces hydrogen gas, oxygen gas, and water. With hydrogen and oxygen. Trying to separate them. Water has connections on the lower part, but by having the electrode separate containers, make sure that you will only have hydrogen and oxygen. Because mixing hydrogen and oxygen in one container is quite dangerous. That makes this explosive. So let's take the example. The plastic container and mix the water with some sodium hydroxide. So mix it well. I also changed the rubber tubes to the longer ones. And also also add this plastic balance. I then add a water mixture to the electrolysis device. I connect power from my power supply. I'll look around for the power. The moment I connect the power, you can already see some bubbles coming out. Hydrogen on one side, oxygen on the other side. And we can see how the pressure is pushing the water downward. And just to show you that this is hydrogen, I get some smoke and water. And I heat the bubble using the hydrogen gas. And to make it explosive, I also add some oxygen from the other tube. And now I light it up. Okay, let's see it one more time. That was a very strong bang. Hydrogen has a lot of energy. It is dangerous, especially when mixed with oxygen.
So again, this is the procedures of electrolysis. Okay, and then the hydrogen gas generated from electrolysis now goes into a fuel cell.
As a residue.
This is the fuel cell.
I think the black very much. The other side with the negative, the side with the red very much. During the chemical reaction, water will be produced. Other two outputs water. For the experiment, I will first try to flow those outputs using the proper plan. I will use the method of the on a piece of board.
So actually, this video shows the electrolysis and the fuel cell together. So water goes in and hydrogen gas generated. Hydrogen gas go into a fuel cell, and then this generate electricity again, and then which can operate a motor or any electric device.
Just as a normal battery. And in the middle, mainly,
okay, this is the fuel cell. As you can see, the proton is also travel in the reverse way in the electrolysis PM. See here is we now have an electron travel from anode side to cathode side, which now is the electric power.
And the process that is called oxidation.
They mentioned the battery. The most typical battery is the lithium-ion battery. Basically, it works like the battery, but the input is we need a H2, and the output will be nothing but the water, but it generates electricity.
Also compared with another battery, water. Not like the rechargeable battery. That's why it's called.
Yes, that's why it's called cell. Cell is the like the generating device. Fuel in this case is hydrogen, and cell is like the generating device generating electricity. So that's why they call it is called a pure cell.
Both devices device will bring hydrogen. With motor. Voltage and dependent. Voltage and the yes. I also look at that. Voltage is and there is a low. Setup. First, yes. Hopefully, that is now very good. That's how the model is voltage is that's around 50. But obviously,
Yes, as you can see that this simple pure cell generate about the 1 volt and then 50 milliampere. And to increase the voltage and ampere, you can certainly increase the area of this cross section and number of layers for the fuel cell. That's why in fuel cell, in real fuel cell, there are lots of stack, multi-layered to increase the power, and also it can be wider, well, many layers to increase the voltage and ampere, the currents. So the only this side, okay, imagine this side, we have a fuel cell, and in here we go, the hydrogen goes in there. This is the hydrogen. So certainly imagine that this is the hydrogen tank, which is supply hydrogen gas into a fuel cell. And then this fuel cell generate electricity, which operate a motor. So this is exactly same as the the electric fuel cell electric vehicle, hydrogen car.
actually, if you want, as well.
So right now we are studying about the electrolysis which generate hydrogen, and this video review the both electrolysis where we generate hydrogen gas, and then a fuel cell it generates the electricity from hydrogen gas. So simply power electricity goes in here, and then power comes out.
Which is not that we're guessing electric motors to get the difficult. For the hydrogen,
Okay. Again, I will copy this. Into our lecture note. As you, okay. We have another figures showing that this multi-layered PM. Okay, you watch the video in rear stacking. Okay, this is a PM rear stacking. You remember, you start with the aluminum, which is a current collector, and then a plate and some transport layer, catalyst, and then a membrane. You remember, you have a multi-layered, and then from here you can from this side you can have this sequence again. So here, this is the anode side, and then we can have the membrane, and then a cathode, and then a membrane and cathode, and so on, so on. So we can have a many multiple layered. That's the practically the way of making this PM electrolysis. Okay, so again, this in PM, the catalyst is the most expensive material, platinum, and so on. That's why the initial investment is very high, but the efficiency-wise, this can reach up to 80% efficiency, which is very high. So initial investment is high, but the efficiency is very effective. While we hope to manufacture the one of these PM hydrogen generators. Okay, well, we actually, I like to go back to the slide which we covered last week. It's giving us the level of energy. The at the bottom, I would say zero energy, H2O, and then we add some energy or power, and then this H2O is split into H2 plus O2. So this is the procedure of electrolysis. Okay, this is a procedure of electrolysis. As you can see, a PM method and alkaline method. And then, as you can see, the energy level of the H2 is a lot higher, as much higher as the addition of the electricity. And as we mentioned, the efficiency can be 80%, means that the energy level we put and versus the energy level it increased. There is a 20% loss. So anyhow, once we have a hydrogen gas, it can be distributed, it can be stored, it can be used for many different locations, many different time. So rather than storing electricity, we can store the hydrogen, and later we can use them. In use them, we now this hydrogen and react with oxygen, giving us the water and then energy out. So this is a reverse procedures, and this procedure is now is a fuel cell. So electrolysis, and this is a fuel cell. So as you can see, outcome output will be the H2O, and then there will be the energy. And then this concept nowadays is the P2G. It's a power to G, a power to gas. So electricity is converted into a gas, a hydrogen, and then hydrogen can be very effectively used. And then the most important point of this green hydrogen is that there's nothing but the water comes out, no CO2 emissions. And CO2 emission is the one we have to reduce. Is a global trend and our the obligation of our generation. So we as an engineer need to fully understand these green hydrogen methodologies, and we further develop the technology such as the reducing cost, increasing the efficiency. That's what we have to do as a mechanical engineer or chemical engineer. Nowadays, there's no barrier between the chemical and electric and mechanical. So we now should work together to movement toward the same goal to generate clean energies. There are a lot things to do for mechanical engineer as well. The okay, well, last week, now we have a better idea of the generation H2. Now, as you can see, how to distribute and how to store. That's the big, the concern and the point. Simply because the hydrogen gas reach very high energy level, meaning that it can be very flammable and can be very light, very, very low density. So that's why last week we covered that let me use this slide. This vertical axis is the density of hydrogen, and this horizontal axis is the temperature. So this is a room temperature with a certain pressure. So to reach a certain level of density, we need to, at the room temperature, we need to have a certain pressure. Otherwise, if we don't have no pressure, almost zero or 1 bar atmosphere, the density will be really low. This hydrogen gas at the room temperature. So that is not the effective way of storing hydrogen. That's why we need a very high pressure gas container. And also another way is to lower the temperature. As you can see, just take a look at this line. If we lower the temperature, to reach the same density, we don't need that much high pressure. We can the pressure can decrease and decrease at the a lower temperature and to reach the same density. Okay, so understanding this phase change of this hydrogen is important. So this figure gives us why the storage is so important, and also distribution through the pipeline. So while we are studying chapter by chapter, to understand all the hydrogen technology. Again, there are a lot of news coming out from the all over the world. So please pay attention to all kinds of technology, and then put your interest and effort into more on hydrogen. And I'm sure that you will have a great chance to, as a engineer, you can find the jobs in the area of a hydrogen related field, hydrogen generation, hydrogen distribution, and fuel cell, the automotive industry, or flying car, UAV, and so on. That's the whole purpose about this class, hydrogen technology. Of course, this is a very new subject for graduate students like yourself. But again, this is I believe, one of the core knowledge you need to study. Okay. Today, I'm sorry to have a class on Saturday, but this is the main point I like to cover this week. So I like to finish now today's class. Okay. Again, we mainly cover how to generate the hydrogen gas using the PM method. Of course, we didn't cover fully about in detail about the chemical procedures and the efficiency and so on. But that's not quite our goal. And our goal is to understand the basic technology. And then there is sub-chapters, scalability and challenges, relate to how to make a bigger electrolyzer to generate a real scale hydrogen gas. So you can study that. So next chapter is gonna be a hydrogen distribution system through a power line, pipeline, and so on. Okay, so this is the all I like to cover today. Okay, thank you so much. See you next week.